ಸರ್ ಕ್ಲಾಸ್ನ ಸ್ವಲ್ಪ ರೆಕಾರ್ಡ್ ಮಾಡಿ.
That's it. Okay. So if you are talking about the same thing with the continuous function, then this will be integration of 2x with f of x dx over the entire range of x. Okay, so I will solve much of the problems on this category in the practical classes. Now next we'll extend this concept and see how to obtain the measures of the spread. So we learned quartile deviation. So coming to the other measures, the most widely used measure of dispersion is standard deviation, and it is also defined similarly for the case of a frequency distribution. So standard deviation and variance. Now, if you remember, variance for a frequency data or a frequency distribution, we indicated it as sigma square, and we said that is equal to sigma f into x squared by n minus x bar square, or sigma f into xi minus x bar the whole square divided by n. So over I equals 1 to n. So this was the formula of the variance. Now we know the relationship between frequency and the probabilities. So we take f by n as the probability. So if this becomes p, then we can define variance of x as summation of all the values of x belonging to the random variable capital X, xi minus x bar. Now here x bar is the arithmetic mean, and when we are talking about the probability distribution, the mean, the arithmetic mean is indicated by expectation of x. So xi minus e of x whole square, and then you have f by n. F by n becomes probability of your x or xi. And if you're talking about this in terms of this formula, the simplified form of the variance, video off ಮಾಡ್ಕೋಬೇಕಲ್ಲಿ recording the problem ಆಗುತ್ತೆ. So this fi by n becomes p. So you can say this as summation over all x, your f by n into x square. So you're talking about x square into its probability minus x bar whole square, and in this case x bar is nothing but e of x. Now if you look into this function, this is your e of g of x. Now any e of g of x is summation g of x into p of x. So in place of g of x I have x square, so I can write this as e of x square. So just look into the square and the brackets. So here we are obtaining the values of x square and then taking its expectation. Here we are taking the expectation of x and then we are squaring it. It's somewhat similar to this. So illi mean substitute ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we will have this as sigma fi xi by n whole square. So this is f into x square, expectation of x square, fx whole square, so expectation of x whole square. So this is how variance is defined, and this is the formula which have to memorize. So variance of a distribution, probability distribution, is expected value of x square minus expected value of x whole square. So the standard deviation of x becomes square root of variance of x. So either you obtain a variance and then take the square root, or just take the square root for e of x square minus e of x whole square. That will fetch you the standard deviation. Now I can take the problems in formula. So variance of x, according first to variance of x indicated by v of x, and v of x has a common formula for both discrete as well as continuous case. Only thing, the difference is how you define the expectation. How you define the expectation, whether in terms of the summation or in terms of the integration. So standard deviation of x is square root of vx, where your ex is the mean arithmetic mean, and that is either sigma x p of x for discrete case over all x, or integration of x into f of x in case of continuous case. So discrete ಕೊಟ್ಟಿದಾರ ಕಂಟಿನ್ಯೂಸ್ ಕೊಟ್ಟಿದಾರ ಅದ್ರ ಪ್ರಕಾರ ಮೀನ್ ಡಿಫೈನ್ ಮಾಡಿ ಫಸ್ಟ್ ಇ ಆಫ್ ಎಕ್ಸ್ ಕಂಪ್ಯೂಟ್ ಮಾಡ್ಬೋದು, ಆಮೇಲೆ ಇ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಕಂಪ್ಯೂಟ್ ಮಾಡಿ. ಇ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಸ್ ಅಗೇನ್ ಬೈ ದ definition of expectation. Expectation of any function is summation of that function with the probabilities, or it is integration of that function with the density function f of x. So compute e of x square, e of x first, then substitute that in the formula of the variance, and this is how we could compute variance and standard deviation. And coming to the other methods, other measures, to define mean deviation from median, mean deviation from mode, mean deviation from mean, quartile deviation, all their coefficients, coefficient of mean deviations, coefficient of standard deviation, coefficient of variation, all measures are well defined even for a probability distribution. ಬರ್ಕೊಳ್ಳಿ the formula ಬರ್ಕೊಳ್ಳಿ. This is e of x, this is e of x square. ಆಯ್ತಾ? So let us take a problem and obtain the variance now. So let me take the distribution of number of heads when 3 coins are tossed. So let me take the relative frequency approach. So I have done the experiment, say for 100 times, and then these are the number of heads. So I have got no heads 50 times, maybe 20, 20, and 10 times all the 3 heads. So you will have the probability p of x as 50 by 100, 0.5, 20 by 100, 0.2, and 0.1. So sigma px equals 1. Therefore, this is the PML. Now, question is computing the mean, variance, and standard deviation, and some expectation. So expectation of that. So we'll find the mean, variance, standard deviation, and then say expectation of 2x square plus 1. Expectation of 2x square plus 1. So this is the question. So to find mean, now I need expectation of x, which is x into px. So we'll have the column x and p multiplied. So I'll get 0, 0.2, 0.4, 0.3, and the total comes to 0.9. So e of x is equal to summation of x equals 0, 1, 2, 3 x into px, and that has come to 0.9. Now to find variance, I need the expectation of x square. So that will be again for all values of x, multiplying x square and px, and then adding them. So first I have to define x square. So I'll use this part. So we have x as 0, 1, 2, 3. Therefore, x square will be considered. Yeah. So 0, 1, 4, and 9. Now do x square into px. So same new frequency distribution alli heng ಮಾಡ್ತಿದ್ರಿ x square compute ಮಾಡ್ಕೊಂಡು f into x square ಮಾಡ್ತಿದ್ರಿ ಇಲ್ಲಿ p of x ಇರುತ್ತೆ p of x into x p of x into x square. So I'll have 0.5 0 then 0.2 4 times of 0.2 9 times of 0.1. The total comes to 1.9. Therefore, P of x square is 1.9. Now computing the variance and standard deviation. Variance is given by expectation of x square minus expectation of x whole square. So it will be 1.9 minus 0.9 square. So which comes to 1.09. That is the mean. Now we compute standard deviation. Standard deviation is square root of variance. So it is square root of 1.09, which comes to 1. Yes, to square root of 1.09. We didn't hear that properly. 1.05. Let's calculator. Root 1.09. 1.044. That is the standard deviation. Next we have expectation of 2x square plus 1. Now if you look into the formula, so expectation of 2x square plus 1 is equal to summation of 2x square plus 1 multiplied with px for all the values of x. So we have x as 0, 1, 2, 3. So I have to now compute 2x square plus 1 for every value of x and then multiply that with the values of the probability. So when x is 0, 2x square plus 1 is 1. Then this will be 3, 9 and 2 into 9 plus 1, 9. So these are the values of 2x square plus 1. Sorry, 1, 2 plus 1, 3, 4 to the 8, 9, 9 to the 18 plus 1, 9. Now do 2x square plus 1 into p of x. So we have 1 into 0.5, 3 into 0.2, 9 into 0.2, and then 19 into 0.1. So the total of 2x square plus 1 px comes to 3.7, 4.3, 4.8. So this is equal to 4.8. So whatever the function and the expectation they have asked, just use the definition, obtain that column and multiply that column with p of x, obtain the total. That total is your expectation of any g of x. Take another problem. So f of x is equal to k e power minus x greater than 0 and 0 otherwise is a PDF. Find k, mean, variance, standard deviation, and then expectation of e power 2x. Maybe expectation of log and e. So there's some more expectations about that. Okay, evaluate k and tell me the value of k. ನೀವೇ ಮಾಡಬೇಕು since f of x is PDF and it is a continuous case. Continuous ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? Range ನೋಡಬೇಕು. x is equal to ಅಂತ ಕೊಟ್ಟಿದ್ರೆ equal to 1, equal to 2, equal to 3, then it is discrete. If they have given the range as in between something, then it is a continuous random variable. So since it is a PDF, integration over minus infinity to infinity, f of x dx must be equal to 1. But here my x is taking value more than 0. So more than 0 andre 0 to infinity. So integration 0 to infinity dx equals 1. This implies integration 0 to infinity k e power minus x dx is equal to 1. Now evaluate the integral and give me the value of k. ಆಯ್ತಾ ಬಂತಾ ಏನು integration of e power minus x is e power minus x by minus 1. So when you put the limits infinity and 0, e power minus infinity becomes 0, e power 0 becomes 1. So I'll be left with k is equal to 1. ಸುಲಭ ಅಲ್ವಾ? Month answer banta. Somesh has got the answer. What about others?
ಸರ್ -1 ಸರ್
ನೀನ್ ಹೇಳ್ಬೇಕಾ? ಚೆಕ್ ಔಟ್
ಸರ್ -1 ಬರ್ತದೆ ಸರ್
-1
ಬರ್ತದೆ ಸರ್
-1 ಬಂದ್ರೆ f of x ಏನಾಗೋಯ್ತು? minus e power minus x, which violates the very first rule that f of x must be greater than or equal to 0. any probability function such that p of x is greater than 0 or f of x greater than 0, summation px equals 1, integration f of x equals 1, only they are called as PDF. So if you're getting k equals -1, then your function is minus e power minus x, which is a negative function. So this cannot be taken as PDF at all. So k equals -1 is not possible.
ಒಂದೇ ಬಂತು ಸರ್. ಒಂದೇ ಬಂತು.
ಬೇಕು ನೀವು ಮೈನಸ್ ಸೈನ್ ಎಲ್ಲ ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ಟ್ರೀಟ್ ಮಾಡಬೇಕು. So you'll have k into integration 0 to infinity e power minus x dx is equal to 1. Now this is e power minus x by minus 1 because k is negative here. So 0 to infinity. When you put infinity first, you'll get e power minus infinity minus when you put 0, e power minus 0 divided by minus 1. Now e power minus infinity. Now how to check what is the value of e power minus infinity? Now you can take your calculator and see. See what is e power minus 1, e power minus 6, e power minus 10, e power minus 30, do e power minus 1000 and see what you get the answer. So what you observed is it already in my first PUC kaltirtira limit x tends to infinity e power minus x is always equal to 1. So sorry, always equal to 0. So this becomes 0 minus e power 0. Any finite quantity power of 0 is 1. So you will have k into minus 1 divided by minus 1. So which get cancelled. So you get k is equal to 1. Now since k is equal to 1, your function is just 1 into e power minus x or e power minus x with x greater than 0. Okay. Now we got your function. Now obtain the mean. So mean is expectation of x, which is equal to integration of x into f of x dx over minus infinity to infinity. But here my function is taking values only in the positive region, positive real line. Therefore 0 to infinity x into e power minus x. Now you have the product of the function here. So see ಎಲ್ಲೆಲ್ಲಿ ಲಾಗರಿಥಮ್ಸ್ ಮತ್ತೆ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಬರುತ್ತೆ ಈ ಆರ್ಡರ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಬರ್ಕೋಬೇಕು ನೀವು. ಲಾಗ್ ಅಂತ ಬಂದು ಪ್ರಾಡಕ್ಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಲಾಗ್ ಫಸ್ಟ್ ಬರ್ಕೊಂಡು ಮಿಕ್ಕಿದೆಲ್ಲ ಫಂಕ್ಷನ್ ಆಮೇಲೆ ಇರಬೇಕು. ಬಿಕಾಸ್ ಯು ಕೆನಾಟ್ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಈಸಿಲಿ say integration of x square into log x, but you could easily evaluate log x into x square. So that's why we say always write the log as the first function. So we're not worried about this trigonometry and other cases. Algebra irutte, exponential irutte. Exponential yavaglu last ಅಲ್ಲಿ ಇರಬೇಕು. So ಅದೇ order ಅಲ್ಲಿ ಇದೆ. So I can take this as u, this as v. So integration of uv is u into integration of v minus integration of v into derivative of u with respect to u. So we have this. So when I integrate the first integration here, I get e power minus x by minus 1, 0 to infinity minus integration 0 to infinity, integration of e power minus x is e power minus x by minus 1 into derivative of u, which is 1 into dx. Now when you put the limits here, not only again we are using another known result. Limit x tends to infinity, x into e power minus x is also equal to 0. The reason is before x approaching 0, e power minus x approaches 0. ಇನ್ನು x 0 ಹೋಗೇ ಇರಲ್ಲ, ಸಾರಿ x Before x approaches infinity, your e power minus x approaches 0. So ಇನ್ನು ಫೈನೈಟ್ ಕ್ವಾಂಟಿಟಿ ಇರುವಾಗ್ಲೇನೆ e power minus x 0 ಆಗೋದ್ರಿಂದ 0 into finite quantity 0 ಆಗುತ್ತೆ. And when you put x is equal to 0, you'll get 0 into 1, so that is 0. So when you substitute both infinity and 0, so this becomes just 0. You have a minus sign here and a minus sign here. So now I can take this as 0 to infinity e power minus x into dx. So which is e power minus x by minus 1 from 0 to infinity. When you put the limit, you get that as equal to 1. So e of x is equal to 1. Now similarly, evaluate e of x square and give me what is e of x square. E of x square ಮಾಡಿ ಅದೇ ತರ what is e of x square? E of x square is integration of x square into f of x dx, which will be integration of x square into e power minus x dx. Now apply the same integral, product of integral, so you'll get x square, derivative of x square, again the same concept. So limit any is a finite agi one formula ಹೇಳ್ತೀನಿ ನೋಡ್ಕೊಳ್ಳಿ. Limit of x to the power of n e power minus x with x tending to infinity, that always goes to 0. So again this term becomes 0 and derivative of x square is 2x. So you will be left with 2 into integral of x 0 to infinity e power minus x. So ಮತ್ತೆ ಇಲ್ಲಿ uv ನೇ ಬಂದಿದೆ. ಸೊ ಮತ್ತೆ ನೀವು ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿ ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿ ಏನ್ ಬರುತ್ತೆ ಆನ್ಸರ್ ಹೇಳಿ. e of x square is equal to 3 ಅಂತಿದ್ದಾನೆ. So mesh is getting 3. It should be 2. Check the steps, Somesh.
Sir, 2.
ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡು, this is nothing but your e of x only. Integration of x into e power minus x is nothing but e of x. So you could just write this as 2 into e of x, which is 2 into 1. Already evaluate ಮಾಡಿದ್ದೀರಾ. So ಅಷ್ಟು ಸುಲಭವಾಗಿನೇ ಆನ್ಸರ್ ಹೇಳ್ಬಿಡ್ಬೋದು. ಇಲ್ಲ ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿ. So you get e of x square is equal to 2 and e of x is equal to 1. So the variance is equal to 1. Standard deviation is also equal to 1. So this is a special distribution where mean equals variance, variance is equal to standard deviation. So this distribution is called as unit exponential distribution, which we'll be studying in detail in chapter 3. So name a distribution where mean equals variance equals standard deviation and the unit exponential distribution. It's one of the distribution where mean equals variance equals standard deviation. Next into obtain expectation of e power 2x. Now expectation of e power 2x. So e power 2x is a very larger function and my x is taking infinity also. So naturally the result should come to infinity. So have e power 2x into f of x dx. So first formula ಬರೆಯೋಣ, ಆಮೇಲೆ form ತರೋಣ. So this will be integration 0 to infinity e power 2x into e power minus x dx. Now e power 2x into e power minus x becomes e power 2x minus x dx, which is equal to e power x dx. Now e power x as limit x tends to infinity is infinity. So this value is equal to infinity. Done. Now similarly, try to define the other spread measures of spread, say mean deviation or average deviation. I'll define it for mean. You similarly define it from mode and median. Now the problem with mode is that sometimes it doesn't exist. So even in case of continuous distributions, there is no guarantee that mode always exists. So if there is a possibility that you could find the value of mode, then one can easily define the mean deviation. So mean deviation from mean. So I'll call that as MD E of x. So there, if you remember the frequency formula, it was summation Fi into mod xi minus x bar divided by capital N. So this F by N becomes probability. So you'll have summation over all possible values of x, mod of every x minus x expectation multiplied by the respective probability. And in case of a continuous distribution, it will be integration of your mod of x minus expectation of x with the function. So ಈ ಕೇಸಸ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು. So you know mod x, any mod g of x takes a negative value of x in the negative region and positive value in the positive region. So you will be using these definitions, simple mathematical definitions or known results in evaluating the integrals. So careful agi adanchu neevu nodkobeku. So mathematical concepts ಗೊತ್ತಿರಬೇಕು. So ಇಲ್ಲಿ e of x ಜಾಗದಲ್ಲಿ ಈಗ median ಹಾಕೊಂಡ್ರೆ you get mean deviation from median. e of x ಜಾಗದಲ್ಲಿ mode ಹಾಕೊಂಡ್ರೆ you get mean deviation from mode. Bari mean deviation from median as well as mean deviation from mode, mean deviation from mean. So mod x formula ಗೊತ್ತಿರಲಿ. Mod x is minus x in the negative region plus x in the positive region.